Hi everyone, welcome to Mike Likes Robots, where we share knowledge to accelerate robotics. And today I'm on to number 15, I believe it is, of the Advent of Code series, where we'll be looking at day 13 of the Advent of Code. So let's open it up and take a look. Today's puzzle is called Claw Contraption. Yesterday's video I managed to finish off day 12 completely, but I stopped before going on to day 13. So let's take a read through this. I'll read it out. Look for timestamps in the description if you'd like to skip ahead. Claw Contraption. Next up, the lobby of a resort on a tropical island. The historians take a moment to admire the hexagonal floor tiles before spreading out. Fortunately, it looks like the resort has a new arcade. Maybe you can win some prizes from the claw machines? The claw machines here are a little unusual. Instead of a joystick or directional buttons to control the claw, these machines have two buttons labelled A and B. Worse, you can't just put in a token and play. It costs 3 tokens to push the A button and 1 token to push the B button. With a little experimentation, you figure out that each machine's buttons are configured to move the claw a specific amount to the right along the x-axis, and a specific amount forward along the y-axis each time that button is pressed. Each machine contains one prize. To win the prize, the claw must be positioned exactly above the prize on both the x and y axes. You wonder, what is the smallest number of tokens you would have to spend to win as many prizes as possible? You assemble a list of every machine's button behavior and prize location, your puzzle input. For example, and here we've got, I'll just read one out. Button A, x plus 94, y plus 34. Button B, x plus 22, y plus 67. And the prize, x is 8400, y is 5400. And then it repeats like that. There are several blocks with similar versions. This list describes the button configuration and prize location of 4 different claw machines. For now, consider just the first claw machine in the list. Pushing the machine's A button would move the claw 94 units along the x-axis and 34 units along the y-axis. Pushing the B button would move the claw 22 units along the x-axis and 67 units along the y-axis. The prize is located at x equals 8400, y equals 5400. This means that from the claw's initial position, it would need to move exactly 8400 units along the x-axis and exactly 5400 units along the y-axis to be perfectly aligned with the prize in this machine. The cheapest way to win the prize is by pushing the A button 80 times and the B button 40 times. This would line up the claw along the x-axis, because 80 times 94 plus 40 times 22 equals 8400, and along the y-axis, because 80 times 34 plus 40 times 67 equals 5400. Doing this would cost 80 times 3 tokens for the A presses and 40 times 1 for the B presses, a total of 280 tokens. For the second and fourth claw machines, there is no combination of A and B presses that will ever win a prize. For the third claw machine, the cheapest way to win the prize is by pushing the A button 38 times and the B button 86 times. Doing this would cost a total of 200 tokens. So, the most prizes you could possibly win is 2. The minimum tokens you would have to spend to win all 2 prizes is 480. You estimate that each button would need to be pressed no more than 100 times to win a prize. How else would someone be expected to play? Figure out how to win as many prizes as possible. What is the fewest tokens you have to spend to win all possible prizes? Okay, I'm getting some thoughts about how to do this already. So my thinking is that B and A have different amounts that you can put in. I'm thinking some kind of binary checking. So I think you can calculate a minimum number of button presses by taking the largest of the coordinates and seeing how many times it fits into the target number. So for example, in this first set, x is 94 and the target is 8400. If you do 8400 divided by 94, that tells you something, and that would be the minimum number of button presses, because you can't get there with fewer button presses, right? So that gives you a lower bound of number of buttons to press. The puzzle gives you an upper bound, which is 100. You can then iterate from the minimum to the maximum and figure out how many of button A to push and how many of button B to push. Problem with that is that if you do the binary check, you may find a second possible solution. So the puzzle is asking for the minimum. So if you iterate up, you are guaranteed to find the minimum, but it might take a lot longer. And I assume the puzzle is built so that it's really hard to just brute force. And if you do the binary check, you might find a second possible solution above your initial possible solution, above the minimum possible solution. So I think I'll write it so that it's binary. And then if that doesn't work, then I will have to iterate fully or come up with another method. When I talk about binary, I mean if the lower bound is 50 and the upper bound is 100, check 50. Check 75. If 75 is too high, go halfway between 50 and 75. Right, 62. If that's too high, halfway between that. Halfway, halfway, halfway. And by doing that, you significantly reduce the number of checks you have to do. Now, there might be a better way of doing it, which uses the y. So let's say I calculate the minimum using the x-axis. I then might be able to narrow it down using the y-axis. For example, I could find the maximum number of button presses in either case, but for case 1, 100 is fewer than a minimum I would get from doing the division. 5400 divided by 34 is more than 100, so my upper bound is fixed to 100, so that doesn't really help. But there might be something mathematical that we can do here. So what I'll probably do is, I think I'll write a brute force solution and I'll look at the numbers that are coming out, and then I'll try and figure out if there's a way to use the y-axis to help. Okay, let's start by parsing the puzzle. So this does have a more complicated parsing use case. Nothing too difficult. I think the easiest thing to do, I don't need it, but the easiest thing to do would just be to write a regex for it. So I am going to write a regex that says x plus and then a group. Oh, this needs to be a backslash. Backslash D, I think, for a digit, which is what I want. Y backslash plus backslash digit star new line. Repeat for button B. Then repeat. And then our prize will be x equals backslash D, y equals backslash D. Okay, so with this regex, I am able to iterate over the groups and just pull out all of the numbers. So let's open up a project. I'll cut to when the project is made with a test case as well. Okay, here we are. I have my test.txt with the example in, and I have a unit test to check that the result is 480. I can now start actually working on parsing the code. So let's have an arcade machine struct, which will have a vector of another type, which would be a actually this will be an arcade, and it will contain arcade machines. Okay, this will be, it'll have machines, which will be a vector of arcade machine, and then that's all from that. And then here I would like to have AXBX. I guess that's fine. I can come back and rename it if I don't like it. So I'm just going to use I32s for ease. Yeah, AX, AY, and then also BX, BY, BY, target X, target Y. Now, I believe the cost of the A and B button is always the same. What varies is the amount it moves. So I don't need to code that. Let's derive debug on an enum arcade error. Leave it empty and then impl from str for arcade machine. Oh, it would just be arcade. Okay, type error. Is it? Oh, it hasn't imported from str. So I need to do that. And then, nope, type error is arcade. And then function from string. Okay, looking good so far. This is the same setup that we've had in previous puzzles. Now I'm going to pull out the regular expression that I built. And this just takes away some of the repeatedly doing splits. This line split, this line split. So let's I want the regex crate. So let's add that. Cargo add regex. And then I would like to use regex. Regex, I think. Now can I do let regex? I'll just comment this out for now. Let regex equals regex. New compiles a regular expression. Yeah, that's right. Going to use this, and then it will be this string here. And then we're probably going to need to escape some of it so that it fits within, or it doesn't get compiled away. Can I just do like R? I think that's working. Okay. We should be able at this point to do a question mark. And then I'm actually going to cargo add anyhow as well, so that I don't have to worry about errors and string parsing and so forth. So this is now going to become an anyhow error, which means that I can use question mark to unpack my regex. To keep the compiler happy, I'm just going to create an arcade with an empty vector for its machines. Okay. So I should be able to match over the entire puzzle string. So I think it's something like for AX, AY, BX, BY, target X, target Y in regex dot captures of puzzle dot filter. There was some code here that pattern cannot match with input type. All right, so I did do this for another puzzle. I can't remember which one it is. So I'm going to open a new window in the root of my advent of code crate and just take a quick look. So it was day 3. We had the regex and we had captures iter. Although I think that's different from what I want. Oh, no. I can map the catches. I think that's what you do. So you do regex dot captures iter on puzzle. I'm going to rename this RE. I think that's just more standard. And then I can do map C to C dot extract. I think it is. Okay, how's that? Doesn't like it. All right, I'm just going to do a quick search for this. So Rust regex. Okay, here we go. And we want brackets with an underscore. And then the rest is correct. Okay, so I need to put this in round brackets and I need to put an underscore here. Then it's okay. I can even do let machines equals dot extract. And then I'm going to map. And then here I can put underscore and then all my variable names like this. And I'm going to return an arcade machine with all of those variable names. And then I can collect it together. Now, if I do that, I should just be able to return machines. This shouldn't work because I need i32s, not strings. But I would hope it gives me something reasonable. It's not formatting because it's having a compiler error, I think. So let me just figure this out. So we are correctly expanding all of those and collecting them together. So why are you upset? Expected bang. I don't understand why it's upset. Is it this? Ah, there's a random curly bracket. That's why. Now it is not happy because it found and string, not i32, which is what I would expect. So I would, at that point, try to parse it. Dot parse. Parse. Literally on all of them, parse with a question mark. Finding it a bit odd that I'm not getting any autocomplete. That's making me think that I've done something wrong. Okay, why is that not good? Oh, right. If I do that, then I can't. So I have to name the fields if I do that. A, Y, B, X. This is getting big. B, Y. I'm tempted to just make this into a new function so that I can just make it easier here. Okay, now we can't use a question mark because we want to use it in a closure. So I will make it into a new function. I think that'll help. So impl arcade machine. We're going to function new from str. New from strs. I'm going to call it. And then it's going to return a result of arcade machine or some error, which I guess will be an anyhow error again. Because it's easiest. So from here I can do, I'll take this whole lot. They're all anstra. Excuse me. Okay, and then let a x, I'm going to overwrite the variable name basically. Parse, question, copy, paste, 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 paste. Okay, y, bx, by, target x, target y. Okay, arcade machine. And then I'm going to copy and paste this lot again. That should do it. Now I can just take all of this. Is it to there? I think it's to there. New from struz, and then plug them all in. I don't use a question mark. Instead, at the end, I do a collect question mark. Type annotations needed. You will become a vector of underscore. Sometimes that works. Question can only be applied to values that try. Okay, how about that? So machines is now a vec of result. This is another one that I did in a recent advent of code where I moved the error outside of the iterator. So Rust check result in iterator. Something like that. This is what I was doing. You can move the result outside. Do I just specify the type and it figures out how to do it? Is that how it works? I want a result of vec of arcade machine, please. I think I'm being too clever with this. Let's filter map it and .ok it. Now I can get rid of this type. And that's it. All right. I'm not too happy about that, but I don't want to sit there spending time on it when it's not even part of the puzzle. So let's skip ahead. We've implemented from string. Let's actually take a moment to check that we're reading in the structure correctly, because that's not for sure. So let's derive debug on the arcade machine and on the arcade. Now I am going to, actually I'll impl a part A on it that returns 0. Impl arcade function part A takes reference to self and returns a usize. I will return 0. Then my arcade is arcade from str puzzle dot unwrap. In the test at least, let result is arcade dot part A. Assert it's equal to 480, and then also I want to print it out. Print line with a debug marker on arcade. So let's run this test and check that it actually gives the results that are in test.txt. Okay. What did we get? Machines, brackets. Excellent. That's not what I wanted. Let's print line trying to make new from struz. See if I get that. Nope. Don't even get to this. So I guess that means the regex isn't matching. So it's probably this code that's wrong then. So let me see. How did I do it? I used an R. Yeah. I don't know if this is going to help at all. I think this is exactly what R is meant to stop you needing to do. Let's try it again. Again, nothing. So basically my regex isn't finding anything. Can I instead print line re.captures of puzzle? None. There are no matches. That seems a bit odd, given that we tested it and it all comes up. Did I put the puzzle in right? Let me close this now. I don't think I need this anymore. Here we go. Test.text. Let's split screen this. We're trying to make new from strings. We've got button A, X, backslash plus. I mean, this looks right. Unless it's my new line that's not working because I'm working on a Windows file and that has carriage returns in. Can I check any new line? Okay, let's replace this \n with \s. And then I'm going to make it a star because Windows has 2 end-of-line characters. So where Linux and Mac use just \n to terminate a line, Windows uses \r/n because there's a different number of end line characters. It wasn't checking, and that was what was wrong, because now we're getting captures and we're getting arcade machines 94, 34, 22, 67, 8400, 5400. Yeah, next one 26, 66, 67, 21, 12748, 12176. Yeah, so it's reading them in right, and I think it's getting all of them because there's 4 of them. Correct. Okay, great. So that was the only problem. Okay, good. So with that, we need to actually start working on the solution. Actually, I might keep this test.text up and just put it on the right here. That should be okay. So I want to find min iters x will be self.a x dot max self.ay, no, bx, and it will be self.target x divided by that. Oh, right. Yeah. We're going to implement this on arcade machine. We're going to say min tokens, function new, function min tokens. Going to take a reference to self and return a usize, 0. Now I'll copy this line of text in and then just comment it out for now. Our part A is actually going to be self.machines.map. I think we'll make this an option of a usize. We could just return 0, but I guess it's kind of more correct for it to be an option because it can be impossible. So I'm going to filter map it, where each machine is transformed to m.min tokens. I should be able to get, although it's not giving me the option. And then I return the sum of it. Why is that not okay? Filter map, because we need to iterate on it. Okay, that's it. So that's the answer to part A. Now we need to write the min tokens function per machine. So min iters x is that. Min iters y will be the same thing, but with ay and by. And then let min iters is iterations. I'm here meaning button presses. So that's fine. That'll be min iters x dot min, and it'll be min iters y, but I need to rename the variable. Okay, so between the two fields, we can have a minimum number of button presses. So now for n in min iters up to 100, up to equal 100, because it's a maximum of 100. And this is the brute force algorithm, right? Let x result equals... now how are we going to do that? We don't know how many button presses it's going to take. We can do n is the smaller of the two, and then divide by the remaining amount. That's probably the way to do it. So this will be for total button presses. Yep. Then our... It has to be the minimum for me to make this work. So in this case, I've got 8400. I've divided by 94. That's the minimum number of button presses it takes to get to that number. However, I could reach it by doing 4 22s plus the remaining 94s, right? So that's still more than the minimum number of button presses, but I can't just assume that all the minimum button presses are going into button A. Some can go into button B. So what I want to do is I want to figure out the token cost. So I want to figure out what the smaller one is, and I want to use the token cost. And I'm right to think about this because in this case, the A button is smaller than the B button for the X. So what I'm going to do is match on self dot AX dot max so this will be, yeah, this is right, BX. So I'm trying to get a couple of variables here. The variables I want are min x and tokens min x. Okay, so for an ordering of greater, so A's x is greater than B's x, then I need to return self.ax and a token count of 3. In the case where, where they are the same, I think I also want A to be the priority. So I'm actually just going to say greater or equal and then finally our ordering less will result in self.bx and 1. Okay, now I'm going to repeat this logic for y, tokens min y. This is going to be ay dot max by, then it will be ay and by. All right. Oh, okay. This is not all right. Oh, that's because I've used max and I want to compare. Okay, and then I probably want the reference here. Check that. That's okay. Is that okay? That's okay. All right, there we go. So at this point, I have the minimum of the two x's. So I can iterate from 1 until the total button presses and check whether it makes up to the number. This is really brute force here. There might well be another way. But I can't think of it right now. I'm trying to hold too much stuff in my head at the same time. Let's just get a brute force result. Then we'll work on how to optimize it. So the X result. Let's work on the X result and let's start doing some comments so that I'm not trying to keep everything in my head all at once. I want to space it out. I want the X result and I want the Y result. I would like to keep a track. If I reach the end of this for loop and I don't return anything, then I'll return none. So that's fine. If I find a solution within this for loop, I'll return it directly. So let's say I find a solution, I can return sum of 100 tokens, whatever it might be. But I need to find the result first. So I'm going to check for n in 1 to total button presses. So we're checking the number of Bs, or the number of the minimum, really. Well, there could be 0, to be fair, so we should use 0. So let achieved x equals n times the minimum of x. Let achieved y is the n times... no, we need that to be the associated. So we can't do that. We don't know what the associated cost is. Maybe what I need to do here is make this a different structure. So I'm going to create a new debug structure for a button, which will be an X, I32, a Y, I32, and a cost, I32. Now, arcade machine will have a button A, which is a button, and a B button. Excellent. And then let A is a button with a AX, BX, and target X. Oh yeah, I need a... Oh right, I do need the target X and the target Y separately. I32 and target Y, I32. Great. So A is AX, BX, and 3. And we need to name those fields. So that'll be X, AX, y, this should be a y, not bx, a y, 3 will be the cost. Let b is the same thing. Oops. Paste it, and then this should be b, and the cost should be 1. Then I should be able to return an arcade machine with A, B, target X, and target Y. So that's the new structure. Is that okay? That seems okay. And then, yeah, we can't do this. That's fine. Let's so I think what I'll do is I will only take the minimum on the X. So I'm going to import function min X, which will return a reference to a button. And then I'll take self.minx, no, self.a.x.minimum. I'm going to create a weird method. It's going to be called orderx, right? And it will return a button and a button, or references to each. Then it will be match self.a.x.compare self.b.x. Ordering greater equal will return self.a, self.b. Otherwise, return self.b, self.a. Okay, these are going to need some references. This one, this one, this one, this one, and this one. For now, actually, I'll get rid of this because I think it's taking up screen space unnecessarily. That should do it. Okay, so now I should be able to do let min x max x is equal to, there we go, self.order x. Then min iters x will be self.target x divided by max x.x. And this is technically still very similar. It'll be AY max BY. That's okay? Right. There we go. Right. So now we don't need this. Achieved x is actually n times min x.x. Achieved y is n times min x.y. Plus total button presses minus n. So if n is 0, total button presses is 100, let's say, times max x.x. That's right. Copy here, max x.y. If achieved x is self.target x and achieved y is self.target y, then we found a solution. In this case, n is the number of min x's. So it's actually let x tokens equals, wait, let min tokens equals n times min x dot cost. Let max tokens, these are bad names. This just means I'm using the min x and the max x variables, not that they are the minimum and maximum tokens. But it's not n, it's total button presses minus n. So then we are going to return sum of min tokens plus max tokens. And that is a usize. So let's convert these to usizes. Like that, and like that. That should be okay. I think that's already the brute force solution. So I should be able to cargo test this, and for some amount of thinking, no, nothing. So something's wrong with what I've done. It thought about it very quickly. Have I still got lots of print lines here? Yeah, I can get rid of that. And don't really need that, but it doesn't hurt to leave it in. Okay, so my left is 0. My part A is therefore 0. So we are getting the minimum tokens. For each of the machines, we seem to be getting no tokens. So let's run the test on just one use case. So instead of puzzle, we are going to make a machine. It will be machine, arcade machine, Neufenstra's. And we're going to make it the first machine. So that will be 94, 34, 22, 67, 8400, and 5400. Okay. Then I would like to assert that machine dot, oh, I need to unwrap it, dot unwrap. Machine dot min tokens is, what's the first one? A total of 280. Yeah, 280. I need to rename it. Test min tokens single machine will do. And then unwrap. Okay, let's debug this one. First, I'll just check that it doesn't work, because that would be odd. Good. We're calling unwrap on a none. That's what we expect. So let's start debugging. I can get rid of this test.txt again now. Debug. Okay, so self.orderx will give me something, right? 94 and 34. Maybe I should just keep this as a separate tab. 94 and 34. That's not the minimum x. So that's already wrong. Let's stop that. Yeah, we are trying to do B and then A, followed by A and then B. Let's stop and debug again. I think we have to recompile after that. Debug. Okay, min x. (22 and 67). That's what we expect. So the minimum number of iterations is apparently 89. Let's check that. So it is 80 plus 40. So 89 is believable because our actual result is 120. Min iters y, I don't think we use. Oh no. Min iters y is 80. Actually, this should be the maximum. So that's a slight improvement to our algorithm. That's an optimization. That's not going to change the result though. Okay, next. Total button presses. So total button presses should now be 89. Yep. N is 0 up to 89. Achieved x is 0 times the min x plus total buttons times n times the max. So total button presses is 89, right? At the moment? Yes. Minus n is 0, so that's 89. So we're doing 89 button presses on button A, essentially, which gives us the wrong answer. So we could already just continue if that's wrong. I'll just make a note to do that. To continue if target is wrong. We only need to check the y if the x is already on target. Actually, is it possible to do a division here instead? So I'm not sure it is. Let's continue on. So achieved y doesn't really matter. Been running for over 60 seconds, that's fine. Self.target x achieved y. Yeah, we don't know these at the moment. So the actual correct number of button presses here is 80. Sorry, so the n would be 40. The total button presses would be 120. So let's stop here when that's the case. Edit breakpoint, n equals 40, and total button presses equals 120. 120. Done. Now let's debug again. Let's see if we hit that breakpoint. We don't hit the breakpoint at all. Why do we not hit that breakpoint? We should hit that breakpoint. Did I get that right? Oh, total button presses. Oh, I've misunderstood something here. Okay, so it's 80 plus 40, right, which is 120. But each button has a minimum of no more than 100 times, right? So it's not between the two buttons, it's between both of them. So actually, I'm going to do a naive thing here and just put it up to 200. Now we run it again. Okay, that passed. And really quickly. I'm expecting this amount of like brute forcing to take a long time. Okay, it passes. I mean, we have working code. I'm not happy about it. I'm sure it can be better, but well, one optimization that I've already said we can do is if achieved x is not equal to self.target x, then continue. Then we check y. If achieved y is not target y. I took a semicolon by accident there. X, control D, Y. Then, and only then, do we calculate the tokens. I'm going to rename this because I think it's a terrible name. So this is going to be min by x and max by x, which will be min and max. I'm also going to rename min x to be min by x, and max x to be max by x. Okay, so they're better variable names. Right, let's write our main function and try it out. Let puzzle is include string. Puzzle test.text. I am fully expecting the full input to be way too big and complicated for this to work. So we'll find out soon enough. Let arcade is an arcade. From str puzzle. Then we're going to give it an expect. So unable to parse puzzle input. Then we are going to print line. Part A is arcade dot part A. Let's get the puzzle input. Is it huge? It's hefty, pretty hefty. So yeah, I think we'll be able to calculate it, but it will take a few seconds. Let's try it. Cargo. Oh, we need to change this to input. Input. And run. Oh, that was actually much faster than I expected. So I'll take it. I'll take it. I don't need to optimize it if it's only taking a fraction of a second to run, even. Okay, that's the right answer as well. Excellent. So let's take a look at part 2. Again, I'll read through it. There's timestamps in the description. Part 2. As you go to win the first prize, you discover that the claw is nowhere near where you expected it to be. Due to a unit conversion error in your measurements, the position of every prize is actually 1 with a lot of zeros. That's 12 zeros, which is trillion. 1 trillion higher on both the x and y axis. Add a trillion to the x and y position of every prize. After making this change, the example above would now look like this. Now it is only possible to win a prize on the 2nd and 4th claw machines. Unfortunately, it will take many more than 100 presses to do so. Using the corrected prize coordinates, figure out how to win as many prizes as possible. What is the fewest tokens you would have to spend to win all possible prizes? Oh, that is very painful. Okay, I'll try it with the current algorithm with some modifications. I guarantee it will not work quickly, and we'll have to think smarter about it. But that's fine. We can leave ourselves in a good position to come back tomorrow and have a bit more of a think about how to do this optimally. I'm just going to reopen this file so it stops telling me there's errors when there's not. Okay, let's have a look. We're going to create a new function, which will be min tokens corrected targets. Okay. Let target x equals. We're going to need to make this a big number as well, I think. Equals self.target x dot plus 1 1 2 3 1 2 3 1 2 3 1 2 3. We'll repeat that for y. We'll replace self.target x and self.target y with just target x and target y. These will now become I64s as well. Can I N I64 maybe? Total button presses I64 as well. Is that okay? Total button presses is here, and it can't do it because min itters is I32. So let's also change these to I64s, just to... Oh, my itters are now wrong, so I should move these up. So I'm going to bracket this and put it as I64. Bracket this and put it as I64. Then it will not be self.targetx, it will be targetx and then target y. Same thing here. And then these again, I'm going to bracket and put as I64. I think actually at this point, I've gotten this far, so I'm going to carry on, but it would have been easier to just change the structure to store I64s in the first place. After all, the new from strs just does a dot parse. That might even still be worth doing, actually. So I'm just going to do that now. I64. Now I don't need all the I64 stuff on min tokens corrected. Whoops. 1. And there. Is that okay? Yes. We don't need to tell this to be I64. Don't need to tell this to be I64. Max by X, that's fine. This has to be I64. This has to be I64. And that's all happy now. Right, so we don't have a way to determine the maximum iterations now. Or do we? Let max itters X. Oh, we don't need to specify all these types. That's nice. Okay, let max itters X equals target X divided by min by X dot X. Let max itters Y equals target Y divided by min by... Oh, I guess we can self.a.y.min. Okay. And then we want the minimum of those is the maximum iterations. So this is the same logic, right? This is saying in order to make 5400, if we're using the smallest possible number, how many do we need of those? And then we might even need to plus one it, I'm not sure. Let max itters is equal to max itters X dot min max itters Y. Right, now we don't go up to 200, we go up to max itters. That should be fine, and then my part A becomes part B, where we do min tokens, corrected targets. We're going to create a new test text. It's going to be part A. We're going to grab this, put it here. This will be part B. Result will be calculating on part B, and it will be... I don't know. I don't know what it is. We can't check it. We'll just check it's 480 and see what it does. See how long it takes. Yeah, that's not going to work. This is the test input with 4 scenarios. That's not going to do it. So we're going to need to be smarter about this, which I thought we would need to be from the beginning, but I got further than I thought we would just with brute forcing. So I'm going to implement the main function so I don't get yellow squigglies telling me things aren't being used. Arcade part B, done. No more yellow squigglies, great. Oops, I've already done this to do. I don't need this anymore, I can remove it, that's fine. And it's still going, so yeah, we need to be cleverer. Definitely need to be cleverer. I can get rid of this as well. So I'm going to spend a couple of minutes trying to come up with a solution. We are very nearly at time, so I'm expecting to not come up with anything right now. I want to get enough in my head that I can think about it overnight and come back for tomorrow's video with an idea of how to do this. So we have min iterations and max iterations. I think it would be interesting to run this test and print some more things out. Min tokens, I can't remember what I called it, increased cost. Increased targets, single machine. And then we're going to do min tokens, corrected targets. That should be it. Now I'm going to get rid of all of these and run one cargo test. This will take, yeah, you can see even one example is taking a horrendously long time. So let's start printing out some things. Okay, we're going to get print line to begin with of min iters and max iters. Min iters and max iters. Let's restart the test using that. And we don't see anything. Ah, okay. I think I'm just going to need to debug it. I don't think anything prints out until the test is finished. So let's take a look. Min iters is a lot and max iters is a whole lot more. Right. So we definitely need to be smarter about this. I think it might be interesting if there's a relationship that we can look at between the button presses and the targets when the targets are smaller. Because if we can find the relationship from when they're smaller, we can apply it to when they're much bigger. So let's see if we can find this deterministically. Let's I would like to, in part A, where is part A? Part A, yeah. For each arcade machine, I'm going to turn this into a function, kind of. I'm just going to fill out the closure more. So let tokens equals m.min tokens, print line, n tokens for machine debug. That'll be tokens, and it'll be the machine m. Then we return tokens. But we don't like that because it's an option. Let's only print it if it is sum. Tokens.unwrap. And here, oh, we can just do if let sum tokens equals tokens. Then print line tokens. Okay, I'm going to just cargo run, I think. Cargo run. Okay, so we've got lots. I'm going to take all of this. Here we go. And I'm going to create a new Google Sheet, and we're going to start looking at some of the I think I may have to be more careful about how I print this out to make it easier. So I want tokens, I want AX, AY, BX, BY, target X, target Y. I think that's it. So let's do that. Tokens machine. And I'm literally just going to do AX, AY, BX, BY, target X, target Y, dot A dot X, MAY, MBX, MBY, M dot target X, M dot target Y. Let's do that. Okay, now we have some data. Here we go. Right. This to the end. Delete. Now we're going to paste our comma separated data in, and it should. No, okay. Tell you what, let's save it as a CSV and then import it. So that's tokens AX, AY, BX, BY, TX for target X, target Y. And then we're going to save into, I'm going to go upper folder, create results, and call it results.csv. Now I should be able to import from CSV. This is a sheet with lots of data on how we can get the result. So we are trying to find the token count given this input data. We've got lots of input data now. We can try and find a way of doing it. So we know, we don't actually know the button presses for each one. That's interesting. So let's think. If I was going to do this, I would multiply by 3. And then I guess this is doing the max down to the minimum. Okay, let's save that. So we are doing max down to min instead of min up to max. Because if you use more of the maximum, well, you're not guaranteed to. I guess min is more correct, but it takes more computation, so we're going to have to deal with that. All right, so max down to minimum. And then as soon as, if we go from max down to min, then as soon as achieved X is too low, continue. Next. Right, because let's take this and put it up here. I may also want to commit this just so that I've got something I can come back to. So I am, for the moment, going to reinstate all of these tests, reinstate part B, cut these out, and tidy up. There we go. Add dot git commit day 13 part 1 complete. Okay, now let's start to mess around. So we're going from min up to max. Now we're going to change it and we're going to go from max down to min. And we're going to have an outer loop. So achieved x will now be n times max by x. And it'll be min by x. Then if achieved x is less than self.target x, we've gone too far and we want to continue on the outer loop. If it's just otherwise not equal, then we will continue on the inner loop. I'm going to take the same logic here. If achieved y is less than target y, continue outer, and we also need to change this to be max and min. Okay, so it's going to go from 100 times the maximum, which will be beyond the target probably, and then it will add smaller ones until it reaches the target. But if there's not enough button presses, actually, can we do... There's something there, I think. Let's think about this for a second. So we're doing... I think we want to go from max iters downwards. We could still do this binary search. So let me get this straight. So the maximum button presses is pretty big, right? It can be again, I'm trying to hold too much in my head at the same time. I need to get some of it down while not forgetting anything. Okay, so let's say I'm trying to make 8 from 3 and 1. So the first thing I'm going to do is get as close as I can with the maximum number, right? So I'm going to get and then I'm going to work downwards. That's it, right? I'm going to do... So it's 8. So it's the target x minus some number times max x. Divided by min x, which should give me m, let's say. Now my iteration I need to check if target.x. So I can modulate this, right? To check that it evenly divides. So I can take the minimum iterations as my n, and I can iterate from n down to 0. Or from n down to min. No, because you can completely make it up with b if you want. So, okay, so I can do for n in max x presses, down to 0. Do that, right? And if I do that, it will tell me that a given value of n has a valid combination of n and m that give me the right tokens. But I can also check y at that point. So I can also do and target y minus n times max x. So I almost want to just repeat this again. Let's try and write this new algorithm. Okay, so we've already got min it is x. So we're going to use that. I'm just going to copy it here and comment it out to help me remember that it's in the right place. So now we're going to do for n in min it is x. Is that right? Min it is x down to 0. Is there a way? I mean, for that trillion, there's still a large number of possibilities, right? I guess I just do it and see how it goes. If let remaining x equals self.target x, subtract n times min by x dot x. If remaining x modulo max by x, don't we want max by x here? Max by x, min by x dot x is 0. If it's not 0, continue. This is not valid. Repeat for y. Let remaining y equals self.target y minus n times max by x dot y. If remaining y modulo min by x dot y is not equal to 0, continue. Okay, at this point we have a valid combination. We know how many n's we have. So we're going to say let m is remaining x divided by min by x dot x, which should give me exactly the right amount. Then I can return and this will be n. We've already got n, so we can times by max by x dot cost. Add on m times min by x dot cost. This will be sum. Otherwise, it's none. Get rid of all of that. How is that looking? We don't have min it is x because it's not been declared. Let's take that. Actually, we might as well just go for min it is, right? Doesn't like this because expected use size and found I64. Fair enough. We can take all of this, bracket it, and as use size. Okay. I'm going to test this, see how far off I am. Fail, failed, and then obviously the part B's are taking an age. Okay, let's cargo test again. What are my results? Oh, that's should be there and there. Let's try that again. Cargo test. Okay, we're getting 0. 0 and none. All right. Let's debug this all over again. Completely fresh algorithm. So I'm pretty sure this is all correct. So the question is here, right? So let's put a breakpoint here and debug the single machine. Debug that. No, don't want to do it. Debug? No debug? Yeah. Min iters is not I64. I know that. It's 89. Okay. Oh, right. Fair enough. We need to do for n in 0 dot min iters, but then we're going to reverse it. Okay. Let's try that again. Cargo test. Okay. It said okay. Let's try it on part A. Part A, cargo test. Okay. We're getting the right result. This should be more efficient than the other one because we're not double looping, right? We're using math to figure out what part B is. So it might even be easier to just overwrite the other algorithm here. Let's take all of this, get rid of it. Let's take this. Now, we do also have an extra piece of data here, which is our max iters. The max iters should say that... Actually, I'm not sure that's relevant. Let's comment these out, and let's try it on a single machine. Let's do that. All right. Self.target X will be target X. Self.target Y will be target Y. Then remaining X, remaining Y. Yeah, test. And failed because we got a huge number, which for all I know is correct. Because, yeah, we didn't have a correct solution for it. So what I think I'll do is cargo run. And it did give me some stuff, to be fair. Let's get rid of this. We don't need it. And it panics because it attempted to add with overflow. I assume that was when it tried to sum. So I think what I'll do is part B will return an option of U128. That is allowed. And this becomes a U128. That means that when I sum and I return a U128, it will give me an actual... It shouldn't add with overflow, and it did add with overflow. Okay. Let's print these out one at a time. What is it asking for, actually, as a solution? What is the fewest tokens you would have to spend to win all possible prizes? Yes. So... if let sum tokens is tokens, can I... Maybe what I should keep doing is print line. Where is it overflowing? Do I get that? Rust backtrace. What add is overflowing, please? U128 should be an enormous number. Like, we shouldn't have to worry about it fitting in, which makes me think it's something in here. Let's turn everything to I128s. cargo run. Still. I'm turning it back to I-64. We shouldn't need more than that. Okay, I need to find out where it is overflowing. Accumulate. So it is probably this sum in part B. Probably is. So let's let mute accumulator equals 0. This will be U128 for machine in self.machines.iter. Let tokens if let sum tokens equals machine dot min tokens corrected targets ac plus equals tokens. Return tokens and comment out. Now every time added tokens for total of ac tokens. We're on return ac. Okay, cargo run. Is part A overflowing? Part A should not be overflowing. Okay, this is now taking a long time to figure out. So probably maybe the third input or another one. It's taking a long time. So today we managed to complete day 13 part 1. And I think we made good headway into part 2. But there's a key thing to recognize here. We took our brute force algorithm and turned it into a more efficient algorithm. I'm sure it can be made better. I think there's something in the maximum iterations here. I think I can maybe figure out that I don't need to go all the way from min iters downwards to get the right answer, right? I can get what the value of m is. Oh, it added a bunch. Actually, that is a good idea. Let's just do it quickly. If n plus m is greater than max iters, continue will I ever get that number? Unlikely, but it shouldn't hurt my algorithm. And it's not adding anything. Yeah, it still seems to be taking the same speed. I'm not sure it helps at all. So I am going to stop here. I'll take a think about this, see if there's anything I can do. I don't think this is one that I can sit and mull over and come up with an algorithm for. I think this is look at the data and figure out how to do it better. So I think tomorrow I'll be back. Maybe I'll have had some insight. Probably I will just be plugging away, trying to improve this algorithm. to be more efficient, trying to figure out how to use maths to determine the answer instead of for loops. So I'll stop there. Thank you for watching, and I'll see you in tomorrow's video.